So the basic idea is to express the equation in terms of the same base. And on top of that, we can't have things in a way with it like an operator that's separating terms. It pretty much has to be one base to some power is equal to that same base to some other power. So as we do look at A, we're going to add 2 to both sides. And then the question becomes, what can I do with this 49? How can I express this in terms of a base of 7? 49 is 7 squared. And what happens is, if we have the same bases and they're equal to each other, then we can simply express the exponents equal to each other. In other words, I can do this, or better yet, this. So we can go ahead and take this and solve for x. There's only going to be one solution. It's amazing how you could be in pre-calculus and still struggle with fractions. So let's break this down for you, for those of you that need it. This 1, I could express this as 1 over 1. But I need to have a common denominator. So I can multiply this by 3. This is where I get 3 plus 3. Or 3 over 3, I'm sorry. And then if I add the numerators, I get 5 over 3. So the value of x in this exponential equation is 5 over 3. If you want a good exercise, take this 5 over 3, plug it in here, and see if you get the same result. For this problem, we don't have any multiple operators, but we do have this 4 in this base, and we have a 4 down here, but it can't be in the denominator. So what we're going to propose to you is that anytime that there is something involving a fraction, you can move either the numerator or the denominator on different sides of the fraction bar by invoking a negative exponent. So right now, for example, I have 1 over 4 to the 1 power. What I'm proposing to you is I move this up here, I would have 1 times 4 to the negative 1 power. So the idea is, you've seen those problems where you have like x negative 2, 4, y to the negative 5. And how do you deal with that? Well, this negative exponent goes to the top, and this one goes to the bottom. So for example, this would become y to the positive 5 power, because this one goes up, and this one comes down, x to the positive 2 power. And the 4 has a positive 1 power, so I'm going to just leave it there. Generally speaking, we don't want negative exponents. But in this case, when we're solving exponentials, we require the bases to be the same. And so by invoking a negative exponent, we can force this to be the same base. So what I'm proposing is, if we go ahead and move this up, I will get 4 to the negative 1 power. And now I have my bases exactly the same. And so all I have to do is set the exponents equal to each other and solve. So we're very much in Algebra 1, Algebra 2 territory, except we just have to be a little smarter about what we're doing. So if x is equal to 0, I would propose you could plug that back in here and check to see if it checks out. Oh, this is fascinating. So we have to get these to be the same base. Now, let me ask you this. What is 1 to the 1 power? Well, that's 1. What about 1 to the 0 power? That's 1. What about 3 to the 0 power? That's 1. So may I propose that we set that equal to 3 to the 0 power? And now they have the same base. Oh snap. So we go ahead and set this up. The exponents are equal to each other. This is a quadratic trinomial. This is a classic pre-algebra, algebra 1, algebra 2 type of problem. The scope of this course is not to introduce you or show you how to factor those. If you need remediation on that, you're free to check out the algebra 2 videos I have on this. Factoring non-prime quadratic trinomials. There's 2 of them. This is a very important skill that will be necessary with further work with exponentials as well as when we hit the pre-calculus topic of limits. So suffice it to say that this trinomial factors out to two binomials, and they're going to be as follows. It doesn't matter what order the binomials are in as long as we have both binomials. We separate these, set them equal to 0, and solve. And we get two solutions. Now, both of these solutions should satisfy the conditions of the original exponential equation. Again, I leave it to you as a good exercise to take these one at a time and substitute them in for the values of x, being mindful of order of operations, and seeing if it satisfies the conditions where this whole thing is equal to 1 at the end. Chances are that everything in here will end up becoming 0, and so 3 to the 0 will then give you that 1 value. So this one is fascinating for the fact that we already have the 5 base, except that it's not a clear-cut 5 base. There's a square root of 5. And so you would hopefully recall that a square root technically has a power inside of 1. And there is this value right here that gives it a square root value. And so we can express this as an exponent where it's a fraction. The 2 goes in the denominator, and the 1 goes in the numerator. So for example, if we gave you x, the cube root of x squared, we could express that as a fraction where the 3 goes on the bottom and the 2 goes on top. So I can express this as x to the 2/3 power. Or if I have the 5th root of x to the 3rd power, I could express this as x3 over 5. So we have 5 to the 1/2 x squared is equal to 5 to the 1/2. And they have the same base, so we can set exponents equal to each other. And they're both 1/2, so we need to get this x by itself, so I can multiply both sides by the reciprocal, 2 over 1. These cancel out and these cancel out. And no, it's not equal to 0. Because here, if you need to be technical about it, 1 times 2 is 2. 2 times 1 is 2. 2 divided by 2 is 1. So don't tell me it's 0, because it's 1. At this point, this gets really interesting. We can do this a couple of ways, but we're pre-calculus, so this is the pre-calculus way. I'm going to square root both sides. And when I square root both sides, I pick up a plus or a minus. And the square root of 1, well, that's 1. So this is how we would do it if you are comfortable pre-calculus students. But if you're slightly uncomfortable pre-calculus students, then we would express this answer as x is equal to a positive 1 and x is equal to a negative 1. So you could separate those two. Now, if you didn't like the little thing with the square root, well, then there's another old-fashioned way to do this with Algebra 1 skills. I could move this 1 back over here, so I can subtract 1 from both sides and make it equal to 0 because I moved it over. And this is called a difference of squares. I'm only doing this if you're not comfortable pre-calculus students and you are missing the algebra at this point. Then I'm taking you back to Algebra 1, and this is a difference of squares. So this ends up being where you have the two parentheses. One's a plus, one's a minus. Each of them gets an x. And then the square root of 1 is 1. So that goes here and here. You separate them. You solve. And I'm running out of space. My bad. But look, you get a negative 1 and a positive 1 answer like we did with our pre-calculus method. So if you like doing my work, then good for you. I mean, as long as you get the correct answer in an honest way, I'm cool with that. But if you're trying to be a little bit more sharp about this and save yourself some time and you have a deep understanding, I think the square root method is the way to go. And when you square root, you pick up a plus or a minus. For your summary, well, there was a common process that we observed in all 4 of these examples. And I gave you some hints in the left column as well. But formalize everything and summarize it and explain in words in general what we do with these kinds of problems.